Good day, guys. This is your tutor engineer. I am back with part 2 on Euclidean geometry series. If you missed part 1, don't hesitate to go back to it and just check what we did on part 1. Now we're going to do part 2, so let's just get on with it. So if you have a question like this in Euclidean geometry, it's always better to just simplify the question first and understand it much better. Then it's going to be easier for you to come up with a solution. So let's have a look. Let's make an example. If maybe you have a cycle like this one, and then the statement says A and B and C are points on the circumference on the cycle with center O. So immediately when they mention center O, that means the theorem of angle at the center is twice the angle at the circumference should come to realization. So O is the center of the cycle. So I can already realize that there's a marking of 70 degrees, and then that's the whole angle O, and that's the angle at the circumference, which is angle C, which is related to angle O, right, with that theorem that I've just mentioned. So the question continues to say AOB is the diameter of the cycle. So there is the diameter, right? So and then AOD is 70. So the question is calculate angle C given reasons. So angle C, we've already mentioned that angle C is the angle at the circumference. So if for instance they say AOB is a diameter, we know that all diameters are straight lines, so they have an angle of 180 degrees. So I can say this angle here from A to B is 180 degrees. Right? So that's the angle on a straight line. It's a diameter. And then we're told that the other angle here, which is this AOD, it's given as 70 degrees. So it's easy now to calculate angle C. So angle C, you can see it is formed by DO and OB. So the angle at the center, okay, let me just write down my notes here. So I'll say the angle at center, that is on arc dB, right? So the angle at the center is equal to, actually, it's 70 degrees plus 180 degrees, right? What would that give us? So 70 plus 180 would give us about 250 degrees. So that would be the angle at the center. That's the entire angle. Then we're looking for angle at the circumference. Remember the theory that I mentioned, the theorem. So that means I'll say 2 times angle C is equal to how much? 250, the angle at the center. So that would be maybe my reason to say, for making this statement, I will say angle at the center is equal to 2 times angle at circumference. That would be the reason. So if I were to continue with finding angle C, I would say angle C then would be 250 divided by 2. So the answer would be 125, right? So that's the end. So that's the end. So remember, someone might wonder, why is it 5 marks? So just for you to maybe make sure that you maximize on the marks, just make sure that your steps are clear. So you start by saying AOB is 180 degrees, right? So the reason is the diameter is a straight line, right? So the diameter is a straight line, right? You can start by that statement and then formulate the angle at the center, and then make this statement for angle at the circumference, and then calculate the angle at the circumference. And that's the end of today's lesson. Stay tuned on the third part on our Euclidean geometry series, and if you like the video, hit the like button and consider subscribing, and cheers. See you next time.